relation is a function, it's often very useful to use function notation. Now, function notation, we use it for a couple of reasons. One, it's an efficient way to talk about multiple functions at once. And then two, if you give me an input, it's a quick way to ask the question for the output. So you'll see that in a moment. I'm going to walk you through the idea behind function notation. So take a look at the given function, y equals 2x minus 5. What is the independent variable or the input? X. And then if we talk about the output or the dependent variable, we have y. So y depends on x, and we would say y is a function of x. Then we could write it as y equals f parentheses x, function of x. So that's how we write the function notation. Y is the same as f of x.
Okay, let's go ahead and rewrite that function above then. Using substitution property, I can now say f of x equals 2x minus 5.
And the way we read that is f of x. I know we've said that a couple of times, but it might help you to write that in. F of x equals, and then 2x minus 5.
Perfect. So now we know f of x is our output, x is our input.
Now that we have f of x equals 2x minus 5, I said that it was an effective way to ask for an output given an input. So look at our example, f and then parentheses 2. What changed there? The x became a 2. Well, this is why it's a nice, efficient way of doing it. The input is 2, and I go ahead and rewrite that f of x equals 2x minus 5 above it, and I notice that the x has been replaced by 2, so I go on the other side and I replace the x by 2. So f of 2 equals 2 times 2 minus 5. 4 minus 5, negative 1. So f of 2 equals negative 1. Do not be tempted to divide out 2. Remember, this is not function notation. It's not f times 2.
For the next one, it looks like we have f of negative 3. So my input this time is x equals negative 3. Same function, so I'm just going to replace my x with negative 3, and I get f of negative 3 equals negative 11.
So now, of course, we want to make sure you can do it. We're going to change the function. There is no special magic to f, although it's pretty cool, function of x. But the next function, we're going to go ahead and call it m of x, and really it can be any variable. My input is still the x, so whatever's in those parentheses is the input, and then the m of or f of, it could be anything, right? That's the output. So m of x equals negative 4x plus 1, and we want you to pause the video, try the problems, come back and check your answers.
Okay, let's see how you did. A should be m of negative 2 equals 9, B should be m of 0 equals 1, and then C should be m of 5 equals negative 19. You can pause and check your work if you need to.
All right, let's get to the next one. Now, I said another use for function notation is it's an efficient way to talk about multiple functions at once. So look at number 4. I've given you 3 different functions, but we know which is which because if I say g of x, you know that you should be looking at that middle function. If I say h of x, you should be looking at the third function, and so on. So then when you look at the question, A says g of 5, G, where do I plug that 5 in? Well, I plug the 5 in to the g of x equation. So g of 5 equals 4 minus 2 times 5, figure that problem out, and so on. Pause the video, try the rest. Alrighty, so g of 5 is negative 6, h of 4 is 5, and our last one, f of negative 1 equals negative 4. I hope you did great. If you had a problem, pause it, look at all of the work, check your answer. Last but not least,
of course, we want to get some actual application here, so let's look at 5. So 5, we're going to go ahead and write a function notation, and kind of evaluate this situation. So let's see what it is. We got write a function rule, an equation, to model the cost of renting a truck for 1 day. So we're given the daily rental fee, so $19.95, pretty good deal if I just want to rent a truck for 1 day and sit in it, $19.95. And then the rate per mile, so that's in addition to my daily fee,
is 50 cents per mile.
So the total cost of renting the truck depends on how many miles I drive. So it looks like cost depends on miles. So we could make a function and we'll call it like C of M. Cost depends on miles, or cost is a function of miles. So let's make sure we define a variable. M is going to be our miles driven and C is going to be our total cost. So $19.95 plus every single mile I drive, I'm getting charged 50 cents, so 0.5 M. Okay, so then part B, we have our function rule written. So part B wants us to determine the cost if we traveled in that truck 73 miles.
So now make sure you use the proper notation. C of M, we're going to replace M with 73. So we're going to say C of 73 equals, and then plug that 73 in for M. So 1995 plus 0.5 times 73.
And we get 56.45, so $56.45.
Hey, do you think this is an okay place to use a calculator?
Yeah, there's decimals.
I mean, I guess you could use a calculator here. Remember, overall though, we want to try and not use calculators for every little thing. Like if you punch 2 times 3 into your calculator, no. One of the things we want to focus on this year is making sure that when we are answering a real life question, that we write out the final answer in context of the problem. So, Miss Ryan,
if you've driven 73 miles, the cost of running the truck for one day is $56.45.